So before we get into example 2, let's just sort of reiterate what the derivative tells us, all right? We're going to go over what the first derivative and the second derivative tells us, even though this section is mostly about the second derivative, right? So if the first derivative is positive on an interval, then the function, not the derivative, but the original function is increasing on that interval. And if the first derivative is negative, then f, the original function, is decreasing. Okay, and that's just because the derivative is the slope, right? So if we have a positive slope, right, it's sloping upward as x increases, then the function is increasing. The y values are increasing as x increases. And if it's negative, you can imagine a downward sloping line where the y values are decreasing as x increases. Okay. All right, so the second derivative. Let's talk about the second derivative now, because that's the main point of this chapter or this section. If the second derivative is positive on an interval, right? Now that's the derivative of the derivative, right? So it's telling us about whether the derivative is increasing or decreasing, right? So if the second derivative is positive, then the derivative is increasing, okay? Because it's just a derivative of the derivative. And it tells us that the original function f is concave up on that interval. All right. Now, if the second derivative is negative, right, that's the derivative of the derivative. So if the second derivative is negative, then the derivative is decreasing. And on that interval, and the original function f is concave down on that interval. Okay, so really, second derivative is telling us about concavity, and the concavity has to do with with whether the derivative is increasing or decreasing. Okay, all right. So so let's just kind of get a picture of the different types of concavity we can have, right? Because we can have a combination of things that we can have for a function. We can the function could be decreasing and concave up, right? So that means the first derivative is negative and the second derivative is positive. Okay, so okay, let's go ahead and fill this out. If a function is concave up, right, its slope is increasing. Okay. Notice I didn't say the slope is positive. I said the slope is increasing. The slope is changing, right? The slope is changing because otherwise it would be a line. The slope is increasing, right? Now, we could have a function that's concave up and decreasing, or concave up and increasing. And these pictures kind of give you a sense of what that curve looks like, right? So this is a curve that is definitely decreasing, right? The f of x, or whatever this function is, it's decreasing, but it also has a curvature that's in an upward, it's bending upward, right? And so if the function is decreasing and concave up, the slope becomes, let's see, I'm having trouble with this, so let's see if this will work. All right, it becomes less negative as x increases. Anyway, I don't know if I can get this to behave, but I wonder if I can just move it up to where it's supposed to go. All right, that'll work. All right, if a function is decreasing and concave up, the slope becomes less negative, right? It's negative, but it becomes less negative, all right? Because it's increasing, right? And then if so you can see this next one, we have a curve that is increasing and concave up. And so the slope becomes, right, it's increasing and it's positive, right? So it's becoming more positive. Let me see here. More positive. All right. So, all right, let's see if I can move this again. It becomes more positive. So, okay. That's good enough, I guess. All right. right? It's becoming more positive, right? It's increasing, but it's positive. And then to increase, it's just got to become more positive. All right. All right, now the next one, it says, okay, these are a couple cases where it's concave down. These are both curves where it has a concave down curvature, but one of them is increasing in concave down, and the other one is decreasing concave down, okay? So if it's increasing, the slope is positive, right? And so, oops, hang on. Stupid thing. Anyway, I gotta turn back. Okay, so if it's increasing in concave down, the slope becomes less positive, right? Because it's decreasing, right? Less. So it's kind of what you would expect. Oh, goodness. All right. And then, stupid word. All right, it's less positive, right? So, it might start out with a slope of positive 10 and then go to like positive 2 or positive 1, right? It's going to be less positive. And then if you have this case where it's decreasing in concave down, right? Now, the slope becomes more negative, right? Because if it's negative and it's decreasing, it's just going to become more negative. All right, let's see if this works. More negative. Okay. All right, we gotta need to move on here. Let me just move this up here. More. That's supposed to say more. It looks like move, but you get it. All right. So, all right, let's go on here to this example 2. So we just want to fill in this table with either positive, negative, or 0. Okay, with just these values, positive, negative, or 0. So we're just going to look at each point. So point A is down here. You can see that the curve appears to be concave up, right? But let's actually start with the value of the function. The value of f, right? This is f of x. The value of f is below the x-axis, so the value of f is just the y value, and it's negative, right? So the value of f is negative. F prime at this point is going to be, it has to do with the slope. So if you look at the slope at that point, it looks like, a tangent line. If I drew a tangent line, it looks like it'd have a positive slope, so it's going to be positive. And you can see that it is on a portion of the curve where it's concave up, so that means the second derivative is going to be positive. All right, let's keep going. Now, if you want to pause the video and just answer these yourself, that's perfectly fine, and you can check yourself when you fast forward to the end. Check yourself. All right, so point B, the value of that function appears to be about 2, right? But it's above the x-axis, so the value of the function is the y value, so the value is positive. Now you can see if I draw a tangent line, if I were to draw a tangent line at that point, it has a negative slope, right? So the derivative is negative. And the curvature at that point, you can see it's on the portion of a curve where it's concave down, which means that the second derivative would be negative, right? Because it's concave down on that portion of the curve. All right, so let's keep moving on to C. Now we're still on the portion of the curve where, let's see, where it's decreasing. But first of all, let's start with the value of the function, right? That point is below the x-axis, so the y value is negative, right? And the y value is just the value of the function. It's the slope of at that point, if I drew a tangent line, the slope would be negative. But now you can see that in this portion of the curve, it's concave up, so the second derivative has to be positive. All right. Now D is interesting. Now the value of the function is negative, right? It's definitely below the x-axis, so the y value is negative. Now the value of the derivative, it looks like that is the point where we're changing, right? We're switching from decreasing to increasing. And at this point, if I drew a tangent line, it's pretty horizontal, okay? So if you have a horizontal tangent line, then the first derivative is 0. Got that? And at that point, the curvature is concave up. So the second derivative is positive. And then finally point E, okay? So if I look at the value of the function, right, this point, the y value is the value of the function, and it's above the x-axis, so the value of the function is positive. If I draw a tangent line, the slope, the slope is positive, so the value of the first derivative is positive. And then, now if you look at the curvature here, it's kind of an upside down U shape, and so the second derivative is negative because it's concave down. All right, hopefully that all makes sense, and I'll meet you in the next video.